All right, let's jump right into it. Today's explainer is covering a massive paradigm shift in how we handle cloud-native environments.
Exactly. For decades, the absolute gold standard of IT infrastructure was simple. Just prevent things from breaking. Put up walls and cross your fingers. But today, we're talking about why MTTR matters way more than MTBF, and why recovery speed, not failure prevention, is what truly defines reliability in modern systems.
Yeah, and I want to kick things off with a hard truth that kind of shatters that old school IT mindset. Perfect reliability literally does not exist.
Right? As cloud architects, as SREs, we feel this in our bones. In modern distributed systems, failures aren't just, a slight possibility, they are an absolute inevitability. The second we stop pretending we can architect a system that never fails, that's the exact moment we can start building systems that actually survive when they inevitably do.
So here's our roadmap for this explainer. We'll hit the illusion of zero failures, define MTBF and MTTR, walk through the reliability lifecycle, dig into some core strategies to reduce MTTR, and finally, look at measuring operational excellence.
Okay, kicking off with Section 1, the illusion of zero failures.
For the longest time, the core assumption in operations was just fewer failures equals higher reliability. Teams would build these massive, tightly coupled monoliths, surround them with manual gates, and just pray nothing went down.
But man, modern cloud architectures completely blow that legacy assumption out of the water. We aren't running single servers in a closet anymore. We're orchestrating hundreds of microservices, dynamic Kubernetes clusters where pods are spinning up and down literally by the second.
Absolutely. Throw in globally distributed databases, this massive, endless web of third-party API dependencies, and the entropy is just off the charts. A network link flaps, a noisy neighbor eats your compute resources, or an external payment gateway drops out. You simply cannot control all those variables.
Which brings us to Section 2, defining MTBF and MTTR.
Right, so since we know we can't stop every failure, how do we actually quantify our reliability? Well, first up is MTBF, or mean time between failures. Historically, this was the ultimate metric in traditional hardware-heavy infrastructure. If you're managing physical hard drives or legacy mainframes, you definitely need to know how long that component's going to last before it physically degrades.
Exactly. It's a measure of physical longevity. But here's the thing. In complex, distributed software ecosystems, tracking how often a failure occurs gives you a wildly incomplete picture of what your customer is actually experiencing.
And that brings us to MTTR, mean time to recovery. This measures exactly how fast your services bounce back after a failure actually hits.
And in cloud-native systems, this recovery speed is honestly the whole ballgame. Think about it. If a Kubernetes pod crashes, say 50 times a day, but your architecture automatically spins up a replacement in 2 milliseconds with 0 drops requests, the user literally doesn't care. The failure happened, sure, but the impact was absolute zero because the recovery was basically instantaneous.
So this highlights the true paradigm shift we're talking about. Traditional engineering culture beats it into us to prevent failures, artificially inflating that MTBF.
Right, whereas modern thinking, which is really driven by core SRE principles, dictates that we focus our engineering cycles on rapid recovery. By designing for failure and building self-healing architectures, we actively drive down that MTTR, and that protects the business so much more effectively.
Moving on to Section 3, the reliability lifecycle. To really operationalize this rapid recovery, we have to look at the anatomy of an incident, like where can our teams actually intervene?
Right, and breaking it down into 5 distinct phases makes it super clear. Stage 1 is the failure itself. Stage 2 is detection, where your telemetry actually flags the anomaly. Stage 3 is response, which is all your triage and fast communication.
Then Stage 4 is recovery, getting the service restored and validated. And finally, Stage 5 is getting back to normal operations. If your actual goal is reducing MTTR, your entire engineering focus has to be laser-targeted on shrinking that critical gap between Stage 2, detection, and Stage 4, recovery. When we look at the big picture of how these metrics map out across the lifecycle, MTBF is essentially just measuring the dead space between the failures.
Exactly. But MTTR? MTTR is a composite of those crucial middle phases. It's how fast your observability stack sees the problem, how fast your automation or your team reacts, and how fast the system is fully restored. The goal isn't dodging the failure entirely. The goal is sprinting through those middle recovery phases as fast as humanly or algorithmically possible.
All right, Section 4, strategies to reduce MTTR. We've talked a lot about the philosophy here. Now let's get into the practical solutions. How do platform engineering teams actually make this faster recovery happen? Well, it all starts with this one core mandate. You can't prevent every failure, but you absolutely can improve recovery.
So here's the actionable roadmap. First up, observability. You simply cannot fix what you can't see. Getting robust metrics, logs, and distributed tracing in place means you're detecting anomalies in seconds, not hours.
Second is alerting. You need systems that notify instantly and route actual context to the right on-call engineer. No one has time for alert fatigue during an outage.
Third, incident response. Having structured, blameless procedures means way less panic and much more efficient action.
Fourth, and this is a massive game changer, automation. Automated recovery patterns, like self-healing Kubernetes deployments or automated rollbacks, they literally remove human latency from the equation entirely.
Oh, for sure. Fifth is runbooks. Standardized workflows mean your engineers are executing proven steps at 3 a.m. instead of just guessing in the dark.
And finally, chaos engineering. You have to deliberately inject failures into your systems to test and validate these exact recovery processes before a real outage actually strikes.
Which leads us to Section 5, Measuring Operational Excellence. Implementing all these practices is great, but how do organizations actually measure their success? How do we know we're getting better at it?
To achieve true operational excellence, organizations have to continuously improve 3 specific submetrics: detection speed, response speed, and recovery speed.
Yeah, and to put that into perspective with a real enterprise example, we've seen major e-commerce platforms shave off crucial minutes just by automating their rollbacks. I'm talking about a scenario where a bad deployment goes out on Black Friday, their system detects the error rate spike, triggers an automated rollback, and recovers the service in under 60 seconds. That literally saves millions of dollars in revenue.
That is exactly why these speeds matter so much. When you successfully optimize them, you unlock some very concrete benefits for the whole enterprise.
Absolutely. Faster recovery directly equals reduced business impact. It guarantees a much better customer experience because, let's face it, users rarely even notice a micro outage. And ultimately, it builds stronger overall resilience and proves a much higher operational maturity within your engineering culture.
So as we wrap up this explainer, we want to leave you with a summary of this ultimate shift. The future of reliability engineering is not preventing every failure. It is recovering faster from every failure. That is the true cloud-native way. And that leaves us with one final, pretty provocative question for you and your teams to think about. If the future of reliability isn't preventing every failure, how fast can your architecture recover from the next one?
To start driving down your MTTR right now, audit your observability stack to make sure you have full microservice visibility. Start automating your most common rollback procedures and run regular chaos engineering experiments so you can actually validate those recovery runbooks in the real world.
Thanks so much for joining us for this explainer. We really hope this helps you build faster, more resilient systems.